Good. All right, welcome. This is track 3, 4 o'clock, or track 1, 4 o'clock. I'm Josh Pitts. That's with an S for whoever had the Wi-Fi access point. That was pretty sweet. This talk is about the Backdoor Factory. For those that know it, thank you for being here. Those that don't, thank you for being here. And those that don't care, I don't know why you're here. All right, that's my Twitter handle. I'm a former, well, I am still a Marine, but I got out in 2001. I do pen testing, red teaming, and code reviews, pretty much everything in the security space. The only thing I don't do really is hardware. I don't pick stuff off of chips yet. I write code for fun. My wife says I need new hobbies. And I work at Leviathan Security, and we're hiring. Like every other security vendor, we are hiring. But we're better, and we have a lot of fun. So, the Backdoor Factory. When I first named this, I didn't think it was going to get popular. It's kind of popular now. So, I shortened it to BDF just for this talk, so I don't have to say that over and over again. And then Google blacklists the YouTube video. So, the goal of BDF is to automatically patch executable binaries so that the user does not know that they've been patched. And when I first started this, it was mainly just Windows executables because I thought it'd be cool to automate a process that I learned while taking one of the offset courses. Well, I've extended it to all binary formats because I want to learn how all of them work. Right now it's Python 2.7. That's the GitHub. That's my GitHub account. Please do not log in. And it's been in development for about 2 years. So why? Just 1 second. For some reason, I'm not getting my speaker notes. My apologies. That's not going to work either. So why did I write this? For 99% of the individuals out there, 99% of enterprises, userland is enough, right? Rootkits are sexy. Rootkits, if you're in ring 0, that is awesome. What is it? Can't see my notes, but rootkits are like underwear models, okay? They are sexy. Sorry. I'm just going to read my notes. I hate Mac sometimes. They're rare as unicorns, and most people will never be touched by them. So, but hard targets, you're going to need rootkits, right? You're going to need, to be at ring 0, you're going to need to be below ring 0 in the hypervisor, in the BIOS, in the firmware, right? To hide from the OS. But, for example, Target, that was everything I've read, that was in user space. Then Fisher, except for the exploits to get onto the boxes of the end users that were infected with this malware, it was all user space. RSA attack, this was Poison Ivy, modified. Userland. Home Depot, who knows, I just put that in there. All right, so last year, I presented patching Windows executables with Backdoor Factory. It was just Windows executables. I could patch X86 stage payloads, and that means users can provide their own shellcode. X64 non-stage, that means like a reverse TCP shell. The patching options were append a new section. You could do code cave injection, and also you could do multi-code cave injection if the binary or the payload that you were injecting into it was split into small enough chunks. You could use it in multiple caves. And at the end of the presentation, I said, all right, this is what I want to do. And I wasn't really sure if I could do any of this. I just thought this is like pie in the sky. This would be great. And let me say, it was a great year. So BDF overall was imported into other projects. Veil Evasion. Who here's heard of Veil? Okay. So it's a way to make binaries to deploy on pen tests so that AV doesn't pick you up. All right. Kali Linux, it needs to be updated, but it is in Kali Linux right now. I'm going to submit a patch after this talk. And then Black Arch Linux. So the first thing I accomplished was the x86 stage payloads. The way it works is I took the x86 create thread method so that you could use a staged payload and you can provide your own payload. I ported that over to X64 and I wrote that by hand. It was originally from MSF Venom. Who wrote that was, I think it was Stephen Fewer. And all it does is allocate memory, copy your payload into a separate, into that memory, and then creates a thread and launches it. So now for X64, users can provide their own payloads. I've heard of people actually using like PE files, actually compressing it down so it, because the maximum payload I support is 65 kilobytes, and that's pretty huge if you have a 65 kilobyte payload. And so I've heard of people actually using this as a method to drop other binaries. And I had this in January 2014. All right, so this is our first demo. All right, so make sure I'm in the right place. All right. So I'm going to patch a WinRAR X64. I'm going to use a let's see what we have available. So we have all these payloads available. For this, I'm going to use a reverse shell TCP. I'm going to pick my host, which is 7172.16.42, port 88. So I already have a Metasploit listener set up to make this easier. Now, you'll see that it's looking for a cave of 561 bytes, and that's huge. And there's one cave available. I can hit jump or J, and then it splits that into different sizes so that you have more caves to work with. And code cave, if you don't know what a code cave is, it's just an empty place in a binary that's zeros. And you could put whatever you want in there. It may break the binary, it may not. If it says none here, that means don't use it. I should just hide that. But I'm actually working on a way to solve what I call the code cave injection problem. And the problem is not every cave works because I may be, for whatever reason, it may be a data type that you cannot use. I'm working on a way to get around that. And I think I'm pretty close to solving that. So this can all be automated. So I'm for demonstration purposes, I'm going to append. So I type A. Can everybody see that? Okay. Everybody see that? Okay. I still can use a mouse. Is that good? All right. So I appended it, and I'm going to appended a new section, and it gives that section read, write, execute permissions. All right. So copied over, and this is a Windows 8.1 VM. It has EMET running, but this binary is not protected by EMET right now. It has Windows Defender, and let's see what happens. Yes. All right, I got a shell, and I can also install WinRAR, so it's dual use. This is what Dan Greer talked about with dual use. For those that saw that talk. All right, so there's the first demo. Woohoo! All right. Now back to the boring presentation. All right, so the next format was ELF, and so for those of you who don't know, Linux use ELF, right? Or ELF is the primary format for the NIX environment. It's also the kernel for Linux. It's very stable. It's been around a long time. I think it's more complex than the PE format. And it's been heavily researched. So heavily researched that whenever I asked a friend of mine named Elfmaster, he wrote an article in FRAC issue 67 about K-probes and instrumentation. You should check it out. So like I said, he's a coworker, and the method he pointed me to was text segment padding code injection infection, as he called it. And this was originally from Silvio Cesar in 1999. And this is on VX Heavens, and you can check it out. And he has a whole list of things you can do to the ELF format. This is in 1999. Like I said, ELF is stable. It still works. What were you guys doing in 1999? Silvio was patching ELF files in C. So how does it work? You extend the text segment by page size, and then you patch your code into it. And then you change the program headers and the section headers that are behind that text segment to proper memory and also file offsets to accommodate the new page size. And then you change the entry point to the location of your payload. And then once you're in the payload, you you fork your payload, and then you continue to the original entry point. It's pretty simple. So I added over the year, I added Linux x86 64 in February, FreeBSD x86, Linux ARM Little Endian 32-bit, and a user could provide could provide their own payloads for all of these types. You just got to make sure it's the right chipset. You have to make sure it's the right shellcode or payload, so that if you're using syscalls, it is to that specific OS and chip architecture. Some people tried to submit a pull request for FreeBSD using Linux syscalls. That didn't go well. All right, so ELF demo. So I'm going to patch LS. All right. And then it's the same type of command line usage. So if I want to patch LS, see what we have available. So I have a reverse shell TCP, reverse TCP stager, and then user supplied shellcode. So I'm just going to do a simple reverse shell TCP. You'll see that it checks to see what the chipset is, system V. It gathers the necessary data. It looks at the length of the shellcode you're going to patch, and then we'll patch the binary. So this is X64, right? So let's go ahead and run this. You'll see if it's going to send it back to itself. All right. So there we go. So far we have PE, X64, a couple ELF formats, and next the IAT-based payload. So when you're patching Windows executables, something to keep in mind that compiled code is static code. That's why position-independent code sticks out so far whenever it's injected into an exploit. That's what EMET is protecting against, is position-independent code. So when you're patching a binary, you do not need position-independent code. So you can write your payloads to act just like compiled code. So the best way to do this is to use the import address table. So I got this idea after reading Bypass EMET 4.1 by Jared DeMott. So a quick high-level import address table. It has Windows APIs are in there, and they're called, it's a thunk table, and it has all the APIs that that particular binary needs. And they are in the same location. So let's say you have binary A. Binary A loads in memory. Every single time it loads in memory, the thunk table is going to be the same distance from entry point every single time. Statically, compiled code needs that. Binary B, it'll have different Windows APIs, and the thunk table will be the same distance every single time. And for our payloads, Metasploit uses this. All you need is load library A and get process address. So for those of you that do any Metasploit development, you should already know all this. And the nice thing is that most Windows programs have these two APIs in the thunk table. Not all, but most. So how does this work? I parse IAT for these two Windows APIs. I figured out what their offset from entry point is by looking at the static numbers on disk, and then I take once I'm in memory, I take EDX, because when an x86 binary is loaded in memory, EDX has the entry point, the address of the entry point. So I just take that, what I know is the offsets are, and then I have load library A and get process address. And then I step through and load every Windows API that I need, and I track, basically it's like a shell game. I track the addresses in different registers for load library A and get process address to make sure that I have them available for each Windows API. Right now it's only x86 reverse TCP shell, no stage shell payload yet. It beats EMET 5.0 because it acts like statically compiled code. I released this in May 2014 with another project that I'm going to show here in a second. And for AV evasion, it's pretty good. So appending a code cave, or not a code cave, but a new section on a binary at the end, read, write, execute, should be a red flag for every single AV vendor. If I were to take and put NOPs in a new section on the end of a binary, I would get about the same result. 13 out of 54 antiviruses flag this, because it is suspicious to have that read, write, execute section on the end. But if I go to a single code cave, I get 2 out of 54. And if I do multi-code cave jumping, I get 1 out of 54. And kind of funny is that it's McAfee. Now, I've never had McAfee in a real environment ever catch anything, ever, that I do. Nothing. So this is when you see behaves like, that is their heuristics engine. And so of course on VirusTotal they have it turned up all the way. But if you did this in an enterprise environment, you couldn't open a Word document or a PDF. So I think this is kind of funny. This is what would you call this? A false negative? Or a positive positive? I don't know. A true positive? All right, so next we're going to talk about man-in-the-middle patching of binaries. Any questions right now? This can be interactive. Anybody got any questions on this? All right. All right, so I released this in May 2014, the same time as the IAT payload. And the reason I wanted this out there in the open is because not many websites for serving binaries still do not use SSL or TLS. And this is disturbing. And there was no open source POC. Now, Barnaby Jack, in 2007, CanSec West, he released he showed an exploit of rewriting firmware of a router and then patching PE executables as they went through the router, the home router. Now, those executables would not continue execution. The person would run the binary and the payload would run. But it worked, and this was 7 years ago. And not much has come out. There was a paper in 2008. I found this 2 months ago, probably because of the funny title. Software Distribution Malware Infection Vector. I just think that's a weird title. And I didn't Google infection vector or distribution, and I never found this. So I found it 2 months ago. Their method was they would append their evil code. So what they did is they did streaming patching. So it was extremely fast. It was supposedly written in C. They didn't release the POC. And they would append the malicious code on the beginning of the binary. So what happens at that point is that your icon is going to change. So if the user is looking for a specific icon, they know what it's supposed to be, the user would see this and be like, well, I don't know what this is, if they're smart. But chances are users would run this anyway. I could implement this if people want me to. But anyway, so no public POCs. I tried to find these POCs, and they're just not out there. So I wanted a public one. So here's a short list of sites or projects that do not use SSL. So sysinternals. Does anybody use sysinternals in an enterprise environment? Do you check the digital signatures? I hope so. Microsoft.com. Now, the update process is in the clear, but as long as you stay within automatic updates, you're okay. if you try to update anything outside of automatic updates manually, a couple of those things, a couple of those updates or KBs are not protected. So that's actually kind of an issue. Most AV vendors, so let's say you go to Kaspersky or McAfee, the whole sign-up process, taking your money and everything, is encrypted. But as soon as you click to get the installer, it's in the clear. And it's in the background. So you really, unless you look at how it's being downloaded, you don't know. It is, yeah, Kaspersky is a rootkit. And so is McAfee. I'm kidding, don't sue me. Yes, you're correct. I'll get to that. The comment was that the binaries are signed, and they are. So, yeah, I'll get to that in a second. All right, SourceForce. Most of these are not signed, but they use something called NSIS, and that is a binary self-checker. So what if you're patched with BDF or BDFProxy, you'll get an error when you run the binary saying that it's been modified, but after the payload executes, because I hook entry point. And you can also I've been able to automatically bypass NSIS, but there's so many versions that I would have to build probably like 5 or 6 different ways of checking to see which version of NSIS it is. So that's it's pretty problematic. But whatever. PuTTY, WinSCP, guidance software. Do you guys know what guidance software makes? Yeah, in case. Malwarebytes, Sandbox. I keep going, CNET. But anyway, let's look at live system terminals as a case. So I tweet this. Mark Rusanovich comes back. They are signed. And he's correct. Now, being hackers, what is the next logical step? So removing the PE signature. This is actually pretty easy to do. So you find the certificate table that's in the optional header and the PE header. And it's 8 bytes long. It has the address and the size of the binary. I mean the size of the certificate. You zero that out, and now it's unsigned. And this is default behavior in BDF. So, now, do you know what the 3 types of binaries there are? So there's signed binary, unsigned binary, and a binary with a bad signature. Users are going to run 1 and 2. They might run 3. So Internet Explorer tries to help you out with this. So the top picture is PSExec is corrupt or invalid. That's a bad digital signature, and it gives you the option to close or delete. If you close, it's still on disk. If you delete, it deletes it. So that's good. Now the bottom is the same binary, but without the signature. But this is only Internet Explorer. That's it. Now, how many people use Internet Explorer? So what is that, 8.3%? Yeah, it's not much. So, and Chrome and Firefox do not have these same checks. All right, so once you get a binary, how do you check the digital signature? Well, natively, there's no way on Windows, besides right-clicking, going to Properties, and seeing the tab Digital Signatures, and then checking to see if the digital signature is okay. There's no way natively, without downloading something from Microsoft, see where I'm going with this? From Microsoft to, or you could use PowerShell script or something to check MD5 hashes, or check SHA hashes, or even to check the signature. You can right-click, go to Properties, like I said. So this is a binary that has a digital signature, address, and size in the certificate table still present. Now this is what happens when you zero that out. The tab is gone. So the operating system can't brute force where the certificate table should be. So SmartScreen, let's go on to another useless permission, well, it's not useless, it's just annoying. All right, so what does SmartScreen do? SmartScreen will sit there and tell you that this app is not common, and that's it. It can't tell you if it's malicious. It can't tell you. It's like a father saying to a daughter, "I don't know this guy." That's pretty much it. And so you can actually just run it anyway. And it only warns you once. After that, it's like, okay, go ahead, do whatever you want with your life. But if you Google Smart Filter Windows 8.1, the the first result is, okay, use the smart filter. The next is turn off the smart filter. So, and there's 49,000 results. So people are turning off smart filter. All right, so some features. So I use man-in-the-middle proxy. Man-in-the-middle proxy does all the heavy lifting. What I do is I take and handle every request or response, and I look at it to see really the bytes. I look at the magic header to see if it's a, an ELF, a PE, a zip, a tar. Yes, this supports zip and archive formats. Zip and tar formats. The tar file support was written by Victor Stanchev. He can sling some code, and he definitely helped me out with that. Also, it outputs a Metasploit RC script. The Metasploit console that is catching payloads right now, or shells right now, is what I used to launch that. So this is the BDFProxy config. This is the overall config. Now, there's a very nice config that, because there's some limitations to man-in-the-middle proxy right now, at least when I wrote this, I wrote a really nice config with whitelisting and blacklisting. So there's the overall section. The overall section allows you to configure the proxy before you run it for whatever settings you want. And this is the only part that you need to config before you launch it. Everything else you can update on the fly. And the next request, as soon as you save it, the next request that comes in, it's applied. So this starts the live updating. So if you edit this, like I said, the next request gets applied with these settings. So I have hosts. Hosts are servers that you are targeting, like sysinternals, Microsoft. So when you say whitelist, I want to patch everything coming in. So if you want to set it to just one server, you say, I want to SourceForge. And so you take out all and you put SourceForge. Blacklist is for hosts. I do not want to patch anything for Microsoft. Okay? Keywords is whatever's in the URL path. So if you want to hit, if you want to patch just TCP view, you'll just put that in a whitelist. If you do not want to patch it, so you have a blacklist. For example, I do not want to patch TCP view, Skype, or any DLLs. Now, the target section is how you want to handle a specific chipset or architecture, or OS, actually. And within that, you have the all. And you notice all is 2 brackets. This is it's a hierarchy, so the more brackets, the lower it is in the configuration. So the all sets all, right? So you go through and you set, for every chipset, every operating system, you set how you want to handle payloads for the C2. Now you need to make sure that you don't send a Linux stager to a Windows machine. You will have a bad day. You will segfault on the target. So you set different. This is why I have this config, is so that you can set different ports so that everything works together properly. Now notice that all was two brackets. You'll notice here that sysinternals.com is 2 brackets. What this means is it inherits from all, and then you overwrite anything that you do not want to do or you do want to do. And this, as soon as you save this, like I said, it gets applied. So if you want to make a change, you can also use hosts. You can use, as you see here, I'm using host names. You could use IP addresses. I suggest using both, because sometimes the download comes from a different IP and it really doesn't have a host name. So yeah, so that's the config. And for this conference, for today, this is my setup. I have the internet, which everyone knows, then BDFProxy, and then a Wi-Fi pineapple. Please do not shell shock me. And I'm on a Mac machine. I am living dangerously. All right, so for the demo. All right. I already have BDF proxy running. And let me just start it over. So that's all it takes to run it. Let me tail the oops. All right, so I'm going to tail the log, and there is a log. It's very verbose. You can change it warning, debug. It uses the Python logging. All right, so I start up BDFProxy. You'll notice here that it outputs what your settings are. So you could look at see what your settings are, and this is in a Python dict format. All right, we have our MSF console running. So let's patch some binaries. Okay, so the first thing I'm going to patch is the standard Microsoft tool that they recommend to get for checking MD5 and SHA hashes. And of course, my VM wants to run slow. It's stage fright. Let me just make sure. So I don't know how fast the connection is, whatnot. Let's try. Here, we get back to this. All right. All right. So you'll see here, it's called the availability and description. All right, come on. The file checksum integrity verifier utility. All right, so I can download it here, and so you'll see that it gives me a cave selection like before, but I can just hit A for append, and should forward along. There we go. Now, if I run that, I disabled smart filter like the web said to do. And there you go. I have a shell. Pretty straightforward, right? And the file works normally. All right. Let's look at some sysinternals. Auto runs. Let's run auto runs. Another shell came in. Yeah, just watch this down here. Let's see. TCP view. So I can view my own connection going out. Boy, that would be scary, right? Why is TCP view contacting China? Oh, look. Right there. All right, let's just drive the point home. Let's do Process Explorer. Yay, alphabet. Oh yeah, there it is. Okay. So there's not much lag when you have a fast connection. There you go. And let's see. Process Explorer has a command.exe hanging off of it. And now it's hanging off of Explorer. Okay, so let's see what else we can do. What other sites we can patch. So what I like about PEBear, not only does it have different binaries for this demo, I didn't mean to close that out. It has on the site. So PEBear is an awesome tool if you want to look at the PE file, look at like how the IHC is, where it is in memory. It's actually great if you like working in GUIs. So let's download the 64-bit version. And so this top window here is BDFProxy, if you haven't figured it out. And I look at every request coming in and out. So it's still waiting. It's the connection here. And so this is a zip file. It's not very okay. So that was quick. So what happened is, I'll just step through it. So I get a zip file. I unpack the zip file using temp file and Python. And I look at every single file in the zip file to see what it is, see what it's doing. And so I have a DLL. And so I have in my configuration, I say I do not want to, if it's in a zip file, I do not want to patch DLLs. But it comes across the pebear.exe, and then it patches that. Still going through, look at every file, and then after there's no more files, it repackages the zip file and then sends it on its way. All right. She also has released some Linux binaries, so we'll go ahead and download those. There you go. And it's done. Now realize this is written in Python, and it's not C. Okay? So if an organization with a much bigger budget has or going to have this idea, if they rewrite it in C, there would be no delay to the user. Let's see. So I downloaded the X64-bit binary. There you go. That's let's see. That was that site. Now for the Windows Development SDK installer. There you go. So now I can get development tools and watch what the developer's doing. All right, so we're running short on time. So another one that I was going to show is Malwarebytes. And what's kind of cool about Malwarebytes is that you get 2 shells for the price of 1 whenever you launch the installer. One is regular user and one is as admin. Well, okay, I'll show it. It's kind of cool. I'll just get the straight download. Copy. And you can set what method you use in the config. So you could say, I want to do append only. And you'll notice 2 shells coming in. So 8 came in, and now 9. So 1 is regular user, and 1 is admin. All right, moving on. All right, so another thing I added was a full disassembler, Capstone Engine. If you haven't checked out Capstone Engine, it's awesome. It supports about 8 chipsets. And it's pretty amazing. There was a presentation at Black Hat. And I had my own disassembler in BDF, and it was kind of ghetto. I was trying just to map the entry point instructions, and so I wrote my own. And I would always have an edge case of where I didn't know an instruction. So I used I used Capstone, a full disassembler, and I eliminated about 500 lines of code. All right, so this is the highlight of the talk. So BDF today supports Mako patching, or Mako, sorry, for those pure hardcore OS X fans. I don't know how to say it, but I know how to patch it. OS X is the binary go-to format for Mac. There's also the FAT binary, which holds multiple Mako formats. It's a very straightforward format. I think it's easier to patch than ELF and also PE. So this is the format, and that's it. No, seriously, it's a linked list. So how I do it is I call it the pretext section patching. I released this in a blog post about a month ago. I haven't seen this anywhere else. OS X Reverser said he knew about it, but he really wasn't talking about it. So that's kind of cool. So there's a lot of empty space before the text section. I've had some purists tell me that's for alignment and for other historical reasons and for padding. But I really don't care. I mean, I could put breakpoints in there. I could put whatever I wanted, and the binary would still run. So I figured I could do whatever I want with it. So what I do is I extend the text section forward based on the payload that I'm using. And the text section, pre-text section, is actually really, really large on some of these binaries. We're talking like 2,000 bytes. So what I do is I fix up the text section load command to point to that new, the beginning of the payload, and then I fix up the LC main and LC Unix thread, and these control where the binary starts in memory, and I make sure those point to the beginning of my payload. So for example, this is some zeros before the text section. You see down at the bottom, that's the beginning of the text section normally. So today I support x86, x64, fat binaries, and also signature removal. And the way you do signature removal is that on the end of the binary is where they keep the signature, what do you call it, just the signature tables or just the certificates. And what you do is you remove the load commands that point to that. It's pretty easy. All right, now for the demo. So I got about 5 minutes. I'll demo two things. Everybody good? All right. First, I'm going to patch Safari. For those that don't know, that's the web browser. You can see here that it is an LC main based binary. That means that the LC main is the newer format for finding entry point. And also I removed, there are two signatures on this binary, and I removed those. So many tabs. All right, so you notice I'm on session 9 right now. Let me run Safari to make sure I didn't do anything. Okay, so we're still on session 9. So this is a clean Safari. Now, so I wanted to access my keychain. So I got session 10. Is that awesome or not? And for those that think that I'm faking everything. Oh. All right, one more. So you can provide your own shellcode, and this is going to be fun. Let's do user. So I made a kind of fun little shellcode from Metasploits. Speak up.
Hello, DerbyCon. Shall we play a game? Or do you want me to rustle your jimmies?
All right. Get out. left of my face. Let's continue on. So there you go. That's what I accomplished over this year. Not too shabby. So the roadmap going forward, I'm going to port all the PE payloads to IAT-based payloads. So now with X64-bit, EMET catches position-independent code. So that means Metasploit payloads are going to be broken unless you find a way around it. So I'm going to port everything to IAT-based. I'm going to automate the code cave jumping. I'm going to implement BDFProxy or BDFProxy streaming and add OSX and any other formats that I add. Now the UPX format, I think this is an interesting format. I think you can append a code cave on the format and actually patch it that way instead of trying to decompress it. And also I'm going to add more ELF payloads and also look into the MSI format, which is the installer. It's like a cabinet file, and DMG. So in conclusion, I think that hopefully some people at these companies and projects see this and actually implement SSL and TLS on their sites. And please let your clients know and where you work, check your hashes, and be very careful what you download, because I think this might already be in use. Any questions? I'm already about to be over time. Any questions? Any complaints? All right. Thanks for your time.